All right, so let's do some Unit 6 review math. So this unit has been all about motion, and we're just going to do some review problems really quickly here. Okay, so question 1 says, Kira walks 5 meters north and then 8 meters south. She turns around again and walks 10 meters north. What distance did she walk? So this particular question is asking for distance. Now, distance is just the total distance traveled. Okay, so, and I know that distance is the same number, so we should say total amount traveled. Okay, so this particular question, we just have to add up how far she walked. Okay, so distance is known as a scalar quantity. So it doesn't need direction. So it only needs a unit, no direction. And what I mean by that, our answer is going to be in meters because the units that are given to us are in meters. Okay, so distance is scalar. It's the total amount that's been traveled. So it doesn't matter if you're going north, south, east, west, whatever. It just means that you are adding it all up. Okay, so in this problem, we're told that she goes 5 meters north. Then we're going to add 8 meters because she travels 8 meters south, and then she goes 10 meters, okay? So 10 plus 8 plus 5, if we type that into our calculator, so 10 plus 8 plus 5 gives us 23. So the answer here is 23 meters, okay? So she walks 23 meters total. So the answer would be 23 meters. So if it's distance, you just add it all together, okay? Now, what if this question asked us about displacement? Okay, it didn't, but what if it did? So displacement is basically where you end up in reference to where you started. So where you end up compared to where you started. So in this instance, we start at 0. Okay, we're assuming that we start at 0. This is going to be a vector quantity. So that means it's going to need a direction. Okay, when you do distance, you don't need a direction, but when you do displacement, you do. Okay, so we need a direction. So in this case, she goes 5 meters north, okay? And if we remember our compass, north is up top. Then she goes 8 meters south. Well, if she went 5 meters north and then turned around and came 8 meters south, that means after this particular time frame, she would be 3 meters south, okay? So she went 5 meters up from 0, and then she went 8 meters south, and then so at this point, she would be 3 meters south from where she started, okay? However, it also says she turns around again and goes 10 meters north, okay? So 10 minus 3 would be 7. So in total, she would go 7 meters north. So her displacement would be 7 meters to the north, and it does need that particular unit on there, or the direction. So the distance is 23 meters because in total she walked 23 meters, but the displacement is only 7 meters north because in relation to where she started, she wound up 7 meters north of her starting point. Okay? Question 2 says Jeremy walked at an average rate of speed of 3 kilometers per hour. How far had Jeremy walked in 30 minutes? Okay, so this is going to be a speed problem, so we're going to want to use our cheat sheet for our motion. So speed is equal to distance over time. Okay, so that's going to be the formula we use. Okay, so he walked at an average speed of 3 kilometers per hour. We know that's his speed. Okay. And we want to know how far he walked in 30 minutes. So his time is 30 minutes. But here we have a problem because this time is in 30 minutes and it needs to be in hours, okay? So we know that 30 minutes is half an hour, so we're going to change this to 0.5 hours, okay? So his time is half an hour, and we want to know how far he travels, so we want to know the distance, okay? So we're going to plug this into our formula. So 3 kilometers an hour is equal to the distance over 0.5 hours, okay? Now this is an algebra problem, right? So we're going to have to do some multiplication here. So because the distance is on top and the half hour is on the bottom, in order to get our distance, we're going to have to multiply our 3 times our 0.5, okay? So we're going to have to do 3 kilometers an hour times half an hour and find our distance that way. And of course, this is going to be in kilometers because that's the unit that we're working with, okay? So let me clear this, and we're doing 3 times 0.5, which gives us 1.5. So our answer here is 1.5 kilometers. And so that means Jeremy traveled 1.5 kilometers in half an hour, okay? So now the next questions are going to be the same formula, which is the speed formula. It's just we're going to be solving for speed and time. So we're just going to solve for different variables, okay? So first thing we always want to do when we're doing these problems is identify our different variables. So for this one, we're going to need speed, distance, and time. So a bird flies 320 meters south in 45 seconds. What is the bird's speed? Okay, so the distance is 320 meters. Okay, so we know that the bird has traveled 320 meters, and we know that the time is 45 seconds. We want to know the speed. Okay, so we just have to plug our variables in to calculate. Okay, so our speed is going to be equal to our distance, which is 320 meters, over time, which is 45 seconds. Okay, and we're going to type that in. So 320 divided by 45 is equal to 7.111, so we'll just round that to 7.1. So our speed is equal to 7.1 meters per second. Okay, meters per second is always, or a distance per second or distance per time is always going to be the units for speed. Okay, so time will always be in hours, seconds, maybe minutes. Your distance will always be in meters, kilometers, and then speed will be in meters per second, meters per hour, whatever the time unit is given to you. Okay? All right, so one more time, let's do another speed problem. Okay, so how long does it take for a robin moving at 8.3 meters per second to fly 100 meters? So just like all of these, first thing we want to do is identify our variable. Okay, so our speed here is 8.3 meters per second. And again, I can tell that this is my speed because it's in meters per second. So it's 8.3 meters per second. Our distance is 100 meters. And it asks us how long does it take. So it's asking for the time. Okay, so now let's plug it in. So our speed, 8.3 meters per second, is equal to distance, which is 100 meters, over time. All right, now again, we have to solve for time, so we're going to have to set this up as an algebra problem. So we'll do 8.3 meters per second times the time is equal to 100 meters. Okay, we want to isolate the time, right? Because we want time by itself. So in order to isolate time on both sides, we're going to have to divide by 100 or by 8.3 meters. Because we want time by itself and we want to solve, which is in meters per second. Okay, so let's go ahead and type it in our calculator. So we'll do 100 divided by 8.3. So 12.048, I'm going to round it to 12.05. So so time is equal to 12.05 seconds. Okay, that is our answer. Okay, and so all of these, so 2, 3, and 4 are all that speed equation. So speed is equal to distance over time. It's just we're solving for different variables. So that's examples of how you can solve for each variable. All right, so let's look at question 5, because question 5 is a different equation. All right, so these are acceleration problems. It says find the acceleration of a car that goes from 0 meters per second to 25 meters per second in 10 seconds. So the first thing we need to do is use our cheat sheet to find our acceleration formula, which is right here. Okay, acceleration is equal to VF minus VI over time. And that is initial and final velocity. That's what that VF stands for. Okay, so its acceleration is equal to VF minus VI over time. Okay, so our acceleration, anytime we have these problems, remember you want to write down all the variables you need and then pull them out of the problem. So we have acceleration, VF, VI, and time. Okay, the problem tells us we want to find the acceleration, so I don't know what that is, so I know that's what I'm looking for, which means the other 3 variables should be given to me in the problem. Okay, so a car goes from 0 meters per second to 25 meters per second. Okay, that means the car started at 0 and it ended at 25 meters per second. Okay, since it starts at 0, my initial velocity, because initial means first, my initial velocity is 0 and my final is 25. So for my VI, I'm going to put 0 meters per second. And for my VF, I'm going to put 25 meters per second. Okay, and my time is going to be 10 seconds, okay, because it says 10 seconds here. So now let's plug this in. So our acceleration is going to be equal to our VF, which is 25, minus our VI, which is 0, divided by our time, which is 10. Okay, so the biggest thing about these formulas is being able to identify the variables, because once you can do that, then it's just plug and chug. Okay, so 25 minus 0 divided by 10 is going to give us our answer. So let's go back to our calculator. So 25 minus 0, of course, is going to be 25. Okay, and then 25 divided by 10 is going to be 2.5. So our answer here is 2.5 meters per second squared. Okay, the units of acceleration are always meter per second squared. And this can also help you identify the variables by knowing the units. Okay, so time typically is in seconds. Velocity is in meters per second. So we know that the 0 and the 25, those are our velocities because they're in meters per second. And we know that our acceleration is in meters per second squared, which is our final answer here. Okay, so those are those examples that we did in Zoom the other day. So you can go ahead and answer these questions so you can get the credit for this assignment. And then also have this video for you to rewatch as you go through them, and hopefully will help with some of these problems.